Oh my.
Okay, so let me get you guys.
I can't wait to leave.
What time do you leave at?
1:15. Oh, I have a question. What if you're like signed up for one of the
And they'll come and get you when it's time.
Oh.
Yeah, they'll like.
Like, are you signed up for? I originally wasn't signed up for anything.
You signed up for something.
But then in art class, they were
You
like,
can't like
Who's
social
that?
distance doing that.
you know that I have to do it at 1:15.
Oh,
okay.
No, here, this is good.
But then in art class, come on. Then in art class, Mrs. McDonald was like, oh, the sophomores still need someone who can get to it. And I was like,
Oh,
oh,
boy.
and I was right by her.
No.
So she went, Kinsey, you'd be perfect for it. And I was like, no, I wouldn't.
Oh, boy.
So now I have to do the next one. I'm doing that goal.
I was vaping last one, but I was like,
Like, I'm not your
I'm too lazy.
That was a dot.
This thing is hard.
Don't finish it. Yeah, why did you face then?
I didn't know my eyebrow was gonna itch.
Yeah, boomer.
Hey, boom, just say your name.
I just
have to do eyebrow exercises.
Yeah.
How am I supposed to win it?
Yeah, maybe.
Here, why didn't you volunteer? Aren't you the class mascot?
Yeah, I am.
Aren't you the sophomore class mascot?
Caitlin got yelled at by a senior today.
We're working on
Abby
There's
is.
just really dodgeball and this.
Abby, Caitlin got yelled at. I'm not a senior, so I'm going to. I'll hit my foot.
Why'd you yell at?
Isn't blended chin? So we were walking across the floor and there was like a tape measure thing.
Oh,
and
we
I
were
accidentally
related.
skipped it in the
We're
water.
sitting in high school.
And he's like, look at the ground and rock.
No.
No, you gotta look if there's cake. And I'm like, yeah, because I would think there's just cake. And then she walked away, she's like, what? And she kind of said, are you playing basketball? I accidentally
What did you
saved
do?
her tape measure.
Hey,
Yeah. You should have been like, what? Is this a three? I don't think so. If it is, that's fine.
here's your roast.
Yeah.
Alright, so you guys might want some colors again for,
Is there
your notes.
color supply?
Oh, okay.
So this is probably the first thing that I'm teaching that's new to you in Algebra 2. So, it rhymes, new to you in Algebra 2. But the idea is that this is something that kind of is an application of systems of equations. So it's a way to use systems of equations, and we're going to kind of just dive into it a little bit here today. And just so you know, we have this section, we have 2 more sections after that, and then we'll get ready for a test.
What?
So, with this schedule, this pace, we have to take a test like every other week. Otherwise, because we're double speed from last year, because we're seeing each other every day versus every other day. So we have to do that in order to keep pace.
So like next Thursday?
Probably next Thursday, yeah, likely. So they want us to, so the start of this is talking about, we're gonna be kind of graphing a system of equations here. So it says, given a rectangle with vertices, and they give us 4 vertices. They want us to find a system of inequalities that will result in shading the interior of the figure. So what I'm gonna do is start by drawing this, because right now it just sounds like a lot of kind of gibberish. So I'm drawing our like what they have, the coordinates they have listed there. So here's my rectangle. So they gave us a rectangle. They say find a system of inequalities that would result in shading the interior of that figure. So how would I end up that I would have inequalities that overlap to end up shading the inside of this space. So thinking about the different like maybe lines you have to draw. Yeah, Kinsey, what do you got?
Wouldn't you do like the Y and there's like just a number?
Yeah, so what number would you want to use?
2.
So y equals 2 would draw this line for us. Now, y equals 2 would draw that line. What would get me to shade above that line? How would I change that equation? So it's no longer an equation, but an inequality. You'd say y is what compared to 2? Greater than 2. That would make us shade above that line. So y is greater than 2 would cause us to shade above this line, the next step off the wall. So that would go like up from there. Going off of her lead, what else do you guys think? Yeah, go ahead, Matthew.
Y is greater, or Y is less than 6.
So then we go to 6. So y is less than, and maybe we should be using the equal line to get it solid, I guess. So I think he was catching himself, like y equals 6. But he said y is less than or equal to 6, and that's right, because then we would shade like between these two. Does that make sense? We'd be shading below and above. So this kind of goes well with the question from our homework, because these vertical and horizontal lines. So now we need our vertical lines. So what will our vertical lines be? 1, so x equals though. That would draw it. So how would I get it to shade this way? Yeah, go ahead, Ryan.
Greater than?
Yep, so greater than or equal to, we use greater than or equal to 1. And then how about the other one?
X is the same.
Yep, 4 as well. So that would make us shade the inside of this shape. There'd be 4 different colors overlapping. You probably wouldn't want to do that right now, but the 4 different colors overlapping would cause us to shade the inside of that shape. We're going to do a lot of graphing with constraints like these. And eventually we'll talk about why this is useful in more depth. But the idea with this is, so like a lot of times when companies or mostly businesses are thinking about setting prices and they want to keep something at a certain price. If you stay under this amount, you get a certain membership or something like that. So those constraints are really important. So like being able to set those up. So we're going to define the word constraints. So constraints are either inequalities we write or are given to us. So we just wrote constraints for this example. Those are considered constraints. Sometimes they'll give them to us, sometimes we'll have to write them. Now, you probably have heard the word feasible. That means it's like possible that we can do that. You might hear that. It sounds kind of like fancy business talk. Well, that's just not feasible that we could do that. The feasible region is the area that makes sense. So in this case, it would be the completely shaded in or overlapping area. So it's where it would work. And what linear programming is, in our context, linear programming can be used other ways as well. You might think of computers and stuff with it. We're going to talk specifically about finding maximum and minimum values. says a feasible region, so the area that works has vertices, and they give us these vertices at -3, 2, 4, 1, 2, 6, and 1, -2. It says find the maximum and minimum values of the function x and y, that's 4x minus y. So what they're basically asking you to do is they want you to test these values into this function and find the output of that function. So what I would suggest doing to stay organized is actually making a little chart. So make like a three-way chart here. So we're going to start with the coordinate point. We're going to put it into the equation, which is 4x minus y. And then I'm going to tell you what the outcome is. So like, what's the value of that? And they want us to say, where's the maximum point going to be and where's the minimum point going to be? So I'm going to take these coordinate points and just put them in our chart. And so this is all given to me. So we didn't have to come up with any of this at this point yet. So we're going to take these coordinate points and put them in and like just substitute them in here. So like the x and the y. And then I'm going to evaluate that. I'm going to see what the outcome is. So I have -12 minus 2, so I get -14. Does that make sense? So we're substituting that in. So it's just kind of a weird, like it's just new to us, but it's not too complicated. So again, we'll keep substituting these in. So 16 minus 1. 8 minus 6. And then 4 plus 2, right? So which of the points would be our maximum and which one would be our minimum? Yeah. Yeah, so this would be the minimum point. This one would give us the smallest output. And then the other one would be our max, the 15, because of the output we get from putting those values into the function. Does that make sense?
Yes.
Okay. It's just a different, I mean, we haven't done anything like this before, so it's just kind of getting used to the format and what we're exactly doing here. So this is where, sorry, we have to work a little bit harder in a second here. We actually have to set it up and figure out those feasible region points. So part of your homework today will be just doing this. So just the start of your homework will be just setting up a table like that. So I'm doing an example like each kind of our homework. So just because it's a new kind of idea for you guys. And I'm thinking, sorry, those of you guys who are going to have to leave early for band, I think I might just teach one more part and then just so you guys get that before you have to go, and then we'll probably do our Kahoot if that's okay. You might have to end up missing part of that, but I want to make sure you get the lesson. Sorry, it's a little more important than the Kahoot, the superhero Kahoot or whatever. So,
No.
I know.
No,
Okay.
it's not. Speak for yourself.
Are you in
I'm
band?
No.
Oh, then you're fine. You're here.
Oh, okay. Never mind.
Okay.
Yeah, I guess it doesn't matter.
Whatever you want. Okay. All right. So it says graph the system of inequalities, and then so they give us the constraints. And then they give us the function that we're going to use. I don't know why I put another dot there. So we're going to start with just this top half, the constraints. We're going to graph those. And this might be someplace you want colors if you like to color the different parts. So we're gonna wait on this function, so don't touch the function right now. We're working on just this top half right here. Bless you. I think that was a sneeze. All right, so y is greater than or equal to 2. So what's that line gonna look like?
2.
2, flat, vertical, what?
Vertical.
Horizontal. Please try that. Horizontal. And which way do I need to shade on this one? Y is greater than or equal to 2? Up. I'm gonna go up. It's starting to get a little bit wise about your shading, so you're not testing a point every time. I didn't really tell you this. I don't tell my Algebra 1 class this. If y is greater than 2, you're gonna go up. So you're gonna shade up. So you could test a point, or you could just know where to shade up. I'm gonna wait to shade just so this doesn't become a big mess. How about x, this fancy x here? X is, it says 1 is less than or equal to x is less than or equal to 5. What do you think that means for us? What's that telling us to do? What kind of lines, first of all? What do you think, Brian?
Vertical,
Vertical lines. Where are the vertical lines going to be?
1 and 5.
1 and 5. It's basically saying 1 and 5 are my x values. Oops, sorry, a little curvy there. And then where am I going to shade? Saying x is, yeah, go ahead. In between the two lines. So at this point, you guys, we're shading in between and above the blue line. So we can kind of try to remember that a little bit. And then finally, our last one. Y is less than or equal to x plus 3. Where does that one begin? 3.
3.
And then my slope is
1 over 1.
1 over 1.
Come on, kids, you have to applause me.
What? Oh. Thank you.
Now let's just reason through this without having to shade. If y is less than x plus 3, where do you think we would shade? Down. So the feasible region, the shaded area, would basically be the closed-in region, which would be that whole little trapezoid-y looking thing there.
Oh, sure. I was waiting for someone to acknowledge it.
Well, we were acknowledging you. We just were trying to make it go away without having to. All right. So now they want the coordinates of the feasible region. So what that basically means is, like, where are the endpoints of this space? So, like, where do these lines cross and kind of like stop? So if you look at 1, 2, there's a coordinate. It's like the corner of that shape. That you guys kind of see what I'm doing there? So just grabbing it from the drawing. So then 5, 2 as well. So they're not giving us the coordinates, we're finding them from our drawing.
0,
1,
3?
Well, that just, we don't color all the way over there, do you see?
Oh, yeah.
So the green line, what's that one? The upper, would that spot be?
1, 4.
1, 4. Yep, so like the part that's shaded in, like kind of the boundaries where we need to stop coloring. And then the last one is, yeah, 5, 8.
Kinsey knows.
So we had to find those coordinate points based off of our drawing. Now that we have that, now it wants us to do exactly what we did on the front side now with this function. So now again, we're going to find the maximum min. Now we're going to use that function with our new coordinate points. Okay? A lot of steps, but I don't think any of them are super difficult. It's just getting used to what they're asking you to do. So our function is given to us, and we're trying to find out what, again, the max and min are going to be. And I'm using the coordinate points we found based off our drawing. Guys, check my answers, let me know if I did something wrong. You guys agree with
Well,
them?
I have the same thing as you, so you got it wrong, so did I.
Good company. All right, so our maximum point is which one? 11, so that would be, and the point we're looking at is the 5.2. So this is the max, and initially, oops, can't barely make a box. Initially, you might have looked at that drawing and said, well, wouldn't 5.8 be the maximum because it's the highest point on there? Not necessarily. And then our minimum point would be -5, so the 1/4. So those would be the values that would give us the minimum output. And we're gonna see like kind of a real life scenario of this on Monday. But we're gonna kind of just get used to the process right now. All right, questions?
I say so.
I say scenario.
Data, data, whatever.
I know, I don't know. I think I think about it.
Potato, tomato,
Yeah.
tomato,
Are we feeling okay about things? Do you want,
lettuce, spinach, thank
you guys want to do a Kahoot?
Yes.
I feel confident.
Okay.
Yes, ma'am.
Let